In this tutorial we will cover milling out of engagement type rings, although I should right away clarify that engagement rings in jewelry cam are simply rings that are more complex on one side than perhaps on the other side. So this is obviously kind of an example of something that does resemble an engagement ring, but it could also be a signet, which has a more or less standard shank on the bottom and then a flat or some kind of a decorated top. Engagement simply means that now, in addition to considering the outer sides of the shank, we also have to keep in mind that one side of the ring, the top, will have some sort of sophisticated geometry that we need to attend to. Because of this, we're not able to position it in the same way as the band rings. We can't position them flat and then simply cut away this side. We need to position them looking as if they're lying flat when in the mill. So in order to do so, we also need to create a support by which to hold this ring. I do so by adding a support layer and usually just using something like pipe command and then creating something that looks like a sprue, and you have to make sure that it fits the width of your ring without sticking out anywhere, something like this. So this is the part that will not be milled out. It is the part that will be holding your finished wax to the remnants of the original wax stock. So let's select engagement ring mode, click select geometry, and select all of our ring geometries. Press enter. Next, when it asks for support, we will select our little support, press enter, and confirm that we're positioned correctly. So we are. If our ring was parallel to the chuck, we would have to turn it 90 degrees, but this is correct. When we're milling, it's going to be lying exactly as we expect it to be. And once again, we have to make sure we define our thickness of our stock correctly. So if you have a 22 by 22 block, make sure you define it as such. Likewise, define the height correctly to make sure you don't collide with your tool bit somewhere. Click apply and watch Jewelry Cam do its magic in adding various operations. As before, these toolpaths are added here but not calculated yet, and in order to calculate them we have to either individually select them and press these buttons or press Ctrl F5 to calculate all of them. So let's do that first and see what we get. And here we are with all the toolpaths calculated. Let's have a look. So one of the first things that we see is that for engagement type rings, we have a segmentation of the whole piece into a number of sections, which are then cut piece by piece. We have our rough operations first, the back operation, and the front. Let me hide the other ones for a moment just to give you an idea of which toolpaths come first. So we have carved out essentially the outline of this ring and remove the excess material, and then we begin finishing operations section by section. And in the settings we have a number of sectors and angles, as well as other things such as width factor and tilt limit. These are good to leave at default initially, and then as you gain more experience you can play with them. For example, Tilt limit is how much your A-axis can lift before potentially colliding between your tool tip and the actual chuck. 130 is a fairly good safe amount, but you might find that on your machine you're comfortable with 135 degrees or even 140 degrees and still able to operate. That comes from experience and over time. So as you look at these, you'll notice that we mill sections one at a time from one direction, so coming in from this side to here, and by default our step over size is very fine, so 0.02 of a millimeter. If you require a different step over, you can change that and recalculate the tool paths, but keep in mind that increasing the step over size reduces time, but at the cost of producing a slightly rougher model. So here we can see our step-by-step instructions. Now we're getting into the inside, so we're removing this center material and then pushing it out by making a little diagonal line that forces the circular or cylindrical material out. We have a number of inside operations. These are designed specifically so that we can put some sort of engravings on the inside. And finally we have a few finishing operations. And you'll notice that these last two finishing operations are at the very base of the ring where we have our support. And the reason for that is obviously we want to keep as much support material throughout cutting as possible. That's just a generally good milling principle. We start as far away from the support and we slowly move towards it, not the other way around. Since we're almost always holding on by this amount of material, we will not get as many vibrations, and there's a little chance of this part breaking off somewhere during the milling operation. So all that's left to do here is to view this entire program through our simulator. So here it is. Once again, I'll set the stock to be transparent and workpiece to be visible, and that will give me an idea how my ring's positioned there. Here's our initial operation. Let's make it a little bit faster. It carves away the excess material from the outside, flips it over, and now when we're actually doing our finishing operations, there's not as much material to get in the way. The milling bit doesn't have to go through quite so much wax. Here is our segment by segment work, and as you recall, the number of segments can be set. If you want more or less, you can do that. You can see that the milling is done from several angles, including from the top, to clean out our head. And as you can imagine, because of the various approaches, various directions, and the finer step, this sort of a ring would take longer time to mill out. Despite the complexity of this milling, this too is only a couple of button operation. We need to select our ring, select our support, specify our stock, and calculate our tool paths. Beyond that, you have a working set of strategies for producing this ring. All you have to do is run the simulation to see if you're happy with the result. This looks a little funny, so let's put the stock back on, and Now you can kind of see what's left over of our initial base. Obviously, some of these parts will fall away because they're not being held on by anything, but you can see that underneath our ring is fully milled out and including a little bit of the support. So now we could cut off our support and pull out this ring and it's ready for casting. And let's just check the statistics before we go. Our estimate for cutting of this ring at this resolution is about 3 hours and 6 minutes. So that's how you approach engagement type rings in the Jewelry Cam automatic mode. And the further lessons will cover the other section, the manual operations or custom operations as Jewelry Cam calls it, that you can use to either add to these automatic strategies or use them instead of them for objects that are not rings, for example, earrings, pendants, chains, and the like, or when you have a specific approach to milling that you need to do and the automatic strategy just doesn't quite capture it fully.